Thank you. Thank you. It's my rule never to talk about the talk in the talk. So this is not the talk. What I want to say now is just a couple things that might be useful. So first of all, I'm going to confess the reason I am giving this talk here is that I gave it a month ago at EuroPython and I wasn't happy with it. It wasn't, the pacing wasn't quite right. So I wanted to give it here. And that comes to a few things that maybe some of you who haven't done as many talks, maybe you're thinking about it, might want to know. So first of all, one lesson there is that you never get it right, okay? You just have to kind of do the best you can. I actually did a rough count a couple months ago. I've given over 100 talks in the past 20 years, and I still can't get it right. So don't worry about that if you're thinking about doing that. Second thing that I want to point out from this is if you do have a talk, reuse it, okay? I like this talk, it just didn't go perfectly, so I wanted to use it again. So I wanted to tune it so I could submit it elsewhere. Okay, so that's something else that you might get. And the third thing that I want to say is that if you are thinking of doing a talk, and there are lots of advantages of getting known and getting experience as a speaker, if you're thinking of doing that, here is a wonderful place to get experience giving a talk, okay? You don't have this big sort of lengthy acceptance process. Everybody's really nice. There's not as much pressure. So, you know, they mentioned at the beginning, please submit a talk. Yes, it is a good idea. Trust me on that. And I guess the final thing I'll say is that with all of my years of experience, if anybody wants any help or advice or my opinions, I have opinions about giving a talk, please let me know. I'm actually retired, and as long as it doesn't cut into my playing guitar time too much, I am happy to talk to people about that. So you can find me afterwards, you can find me online, you can find me many places. So that's the end of the not talk. This now is the talk. So I'm going to tell you some stuff about objects. This is a Jupyter notebook that is being presented as slides. You can get it from a GitHub repo, which is nceder/talks, or the little QR code will take you right there. So in Python, we say, I say, everything is an object. And I also know that for some beginners, some people who maybe haven't been around as much, they don't quite know what that means. And you can see there are lots of Google searches. Everything is an object. You know, what is everything? So that's the first thing I'm going to talk about. What is everything? And we're going to test this by using isInstance, which is a built-in Python function that will tell you if thing is an instance of other thing. So we're going to ask, is something an instance of object? And then if it's an object, that means, and we'll see more of this as we go on, that it's also an instance of a class. And so I'll use the dunder class attribute there to find out which class it is. I could also use the type function, but trust me, we're going to get confusing enough in a little while that maybe using dunder class is a good way to go. So start out, is -1 an object? Okay, I can think of many languages where -1 is a data type, certainly, but it is not an object. So if we ask our magic question here, is -1 an object? Yes. And what type is it? It's int. Okay, that's not meant to be surprising. Now what about a function? I started my coding back in the days when everybody did C. And in C, I can tell you that a function is not an object. So what about in Python? If we make a really simple function, and then we ask the same question, is it an object? If so, what class is it? You all know this one, right? Right. Yes, it's an object and it is an instance of class function. Cool. Suppose then that we import a module. I mean, we were just hearing about making packages. We could do that, but let's just stay with a module. Let's say we import the math module. Okay. Is that an object? If so, what class is it? Well, yes, it's an object and it's class module. All right, you might not have known that off the top of your head, but it's not a surprise. Other stuff, well, what about none? None is kind of a peculiar thing in Python, but it is an object and it is an instance of none type, which is off the top of my head, the only singleton type I know of in Python. Okay, what about ... I love ... because it's just so fun to type their ... class. Is that an object?
Yes.
Yeah, there are some people saying yes. If so, what class is it?
Ellipsis.
Ah, good man. It is ellipsis indeed. So those things are all objects. Now, what about these things? Plus, minus, divide, multiply, all of those symbols, those operators. Are those objects? No. Okay, they're kind of the way that Python works. You could imagine a language where those things were objects, but it's not Python. Okay. Oh, question in the back.
That language is called Ruby.
Well, yes. And I'm not going to comment. I'm not going to comment. Okay, same thing with the reserved words in, else, etc. Those also are not objects. Okay, so that gets us to everything is, well, it's not everything, but it's almost everything. Okay, and everything that's an object is an instance of a class. So what about classes? This is the next question. Are classes objects? Again, I know of languages where that is not true. So let's make a class. And yeah, I'm sorry, I've got this running duck joke thing that goes through the whole talk. You just have to put up with it. So if we make a duck class, I mean, it's basically goes back to, you know, duck typing, quacks, like, et cetera, you know the joke. So is a class an object? Okay, if it is, what is it an instance of?
Type.
Okay, as somebody who's been studying here. Yes, a class is an object and its class, AKA its type, is type. Okay, so what about type? Is type an object? And if so, what type is type?
Type.
Okay, so oops, I gotta back up here and make sure I'm in the right spot. All right, so yeah, quite right. Type is an object and its type is type. Just like a class's type is type. You can see why I was reluctant about using the type function earlier because it's starting to get a little bit silly here. Okay, so what about object? We know object is an object. I mean, that's obvious. But if all of our objects so far have been instances of classes, what is object an instance of? Ah, yeah. Well, it's type. And that might be a little bit surprising. Wait, everything's a type? So we know that type is an instance of object because we checked that. But we also know that object is a type. So does that mean that object is an instance of type? Madness. It's true. It's true. Type, our object is an instance of type. So they can't be the same, can they? No. Okay. That's somewhat of a relief, I think. There's a little bit of clarity still left. Okay, so now let's instead of doing this is instance, which is kind of fuzzy, let's ask a specific question, is subclass. So is an object a subclass of type? Nope. Well, then let's flip it around and ask it the other way. Is type a subclass of object? Yes. So where does that leave us? Well, if my slide would advance, it would leave us. Sorry about that, ruining the moment of suspense. Oh, move. There we go. It leaves us with almost everything's an object, and everything has a type, including object, and object's type is type. And so yes, all I could think of to illustrate that was this. Okay. I will add no AI was used. I went it the old-fashioned way and stole it off the internet. But yes, that's kind of where we're at for this part of it. It's a really weird thing. And how do they do that? Well, you could go look at the source code to see how they did that, but it's how the language is designed. Okay, it's kind of freaky in there. So objects are classes. That brings us to the question of how classes work and how instances work. And I'm not going to belabor this too much. This is sort of assuming that you kind of know how classes are. Maybe you don't write them a whole lot, but you sort of know the parts. You use the class keyword and give it a name. You can have methods, and methods usually take, well, methods, if they're instance methods, always take a parameter for the instance, which is called self by convention. It could be anything. I've known people who've gotten amusement out of calling it silly things. Don't do that. It makes your code weird. We can have instance attributes which are attached to the instance of the class. And again, those are attached to self. So all of that we should know. So I've got a duck class here. I told you it's going to be ducks all the way down. And it's got, it does a couple things. So it sets an instance attribute name. So every duck has his own name. I think that's only fair. And it has another method, hello, that basically reports some stuff like its name and its type. Okay, so that's all pretty straightforward. And if we run this, there's no surprise. We make Donald duck. He says, hi, I'm Donald. Cool. If we look at what's in the duck class, we see some standard stuff, but what's I'm calling attention to is we can see it's got the two methods, going to be instance methods, linked in its dictionary. Okay. As I say, the other stuff is pretty standard. And if we look at an instance, we'll see all it's got is the name attribute. Okay, fair enough. Now, that was all kind of setting the groundwork for what we're going to look at now. So first of all, let's think about this. You can make an int object by using int as a function, right? Int parentheses around something, and if it's legal, it becomes an int. We can do that with stir to make string. We can do it with list. We can do it with all sorts of things in Python. So we've established that type is an object, is a class. So can I make a type using type as a function? Well, I'm going to do some stuff here. Yeah, spoiler, the answer is yeah, but let's set this up. So I'm going to make a couple of functions. Now note that these are just functions. They don't belong to a class. Well, they belong to a function class, I suppose. But so init func will take a thing and assign name to that thing. And a hello func will take a thing and print out the name and the class of the thing. Okay, the next thing I do is I make a dictionary. And for the sake of argument, I will call this dictionary namespace. I could call it anything, but let's call it namespace, where I map dunder init to init func, and I map hello to hello func. Okay, and if I do all of that, then yeah, I've got a dictionary that is mapping those identifiers to those two functions. Now, if I take the type function and I give it three things, okay, I give it a name as a string, I give it a tuple of parent classes, and I don't want parent classes now. I mean, object is assumed. You don't need to worry about that. I'm not going to say any others. If I do that, and I give it a dictionary that it can use as a namespace, which I happen to have called namespace, if I do those things, I actually end up with a class. Okay, so you do not need to use, this is exactly the same result as using the class keyword, blah, blah, blah. But instead, you're passing it those three elements to type, and it will create a class for you. And if I were to go ahead and make an instance of my Scratch class, it's called Scratch because we're making it from scratch. If I could do that and make my Scratch there, it works perfectly fine. And you know, it's just as though we'd done it the other way. So yeah, this is kind of the payoff for this bit. Yes, you can actually use type to make a type, which is only logical since you could use int to make an int, etc. But in fact, it's not done very often. It can be done in cases where you're trying to do some sort of code generation or something like that. Can be handy. Okay. So another thing about classes is this stuff with methods. And this is actually something that gets a little bit silly. Now, when you have an instance method, as I referred to it before, the ones that take self, those are also sometimes called bound methods because you don't have to, they're sort of bound to the instance. You don't have to specify the self when you use them. You can say method dot whatever without specifying self or whatever you use for the instance. So what do I mean by that? Well, here, it's a new improved duck, duck Mark II. And it's got the same thing. It's got init, it's got hello, it's got goodbye. And all of this works exactly as you would expect. Duck, hello, goodbye. Again, I don't want to spend a lot of time on that. But the other thing we can do, of course, is we can use, with exactly the same effect, we can use the class to get a hold of that method. But if we do, we no longer automatically pass in the self. We need to be explicit about the self part. So we need to actually say, if we want Donald to say hello, we need to say duck.hello, Donald. And if we do that, it works exactly the same. All right, now, what about this? I've got my Scratch object called myScratch floating around. It's got a name attribute. Can I pass this Scratch object to duck? Will that work? Will that be an error? Will that just not be allowed? Is that a syntax error? Is that a runtime error? What happens? Obviously, none of you have done the silly stuff that I spend my time doing. This is, okay, so, well, what happens is it works just fine. There's no law against it at all. I would not recommend doing this in production code, obviously, but this talk, as you're finding out, isn't about production code. This is about poking at the language to see what it does. So if you take a stick and poke Python this way, that's what it does. Okay, so there we go. Next thing that I think surprises some people, again, this is the same old duck Mark II. I'm just repeating the class so that nobody forgets. And I also am adding down here at the bottom a separate standalone function, right? That's another one that it says, Instead of saying goodbye from thing not whatever, it says farewell, so we can tell these apart if we have any confusion. Okay, so if I execute all of this, I end up with a class and a function, and they work kind of as we would expect, right? You'll notice that when I am calling Donald's goodbye method, I don't need to pass in Donald because that's what's calling it. And when I'm using farewell, that's a function, so I need to tell the function what it is that it's supposed to be working with. All right, fair enough. Now, again, this is the sort of thing that I do to amuse myself sometimes. Let's say that I am going to save duck's goodbye method in a variable just for later, and you'll see why I want to save this in a little while. And instead, I'm going to set duck's goodbye to be equal to my farewell function. Okay, this would be something where, by now Java would be passing out. But no, let's just say we're doing this. So I suppose Ruby would be quite happy about the whole thing, honestly. We'll do that. And I'm going to make a new duck, Daisy duck. And I'm going to call Daisy's goodbye function. Okay, you might have an inkling of what's going to happen, but let's see. So in fact, the farewell function is now Daisy's goodbye method. And Python does not care. It's fine. But here's a question. We've already seen Donald using the old goodbye method. If I call Donald's goodbye method now, what happens? Well, it uses the current goodbye method, which again, if you're used to some other languages that treat these things differently, this is a surprise. And that's what I'm here for, of course, is to bring you a surprise or two. So yeah, that's interesting. And of course, if I delete the goodbye method, which I could do, and I try to call Daisy's goodbye method again, what happens then? Well, by now you're probably guessing we get an error because there is no goodbye method anymore. Okay? But if I glue back on the old one that I saved, see, I've been through this. Yeah, we're fine and everything works again. Okay? So a couple of things to keep in mind here. One of them, of course, is that these bound methods, sometimes they're called instance methods or things like that, aren't in the instance. They are in the class. And an instance, when it goes to get them, looks it up off of the current version of the class. Okay? Second thing is that classes, as we established a couple minutes ago, are objects, and most, not all, but most objects in Python are mutable. They can be changed anytime you want. Okay, to do this, this used to be something that was popular. I'm talking like 15 years ago, whatever. This used to happen much more than it does now. To do this change on the fly is called monkey patching. Okay, and it can make debugging, even with today's debuggers, it can make debugging a real headache. And I always used to tell my students, don't give yourself a headache. You'll have plenty of headaches anyhow. Don't do that. So in general, I would say only do this if you're like me, being silly and just playing around to see what happens. Don't do this in production. But Python being what it is, I'm not the police. I'm not your mother. Do it if you want. Just beware. That way madness lies. Okay? So there we go. All right, this is the last thing. And I want to talk a little bit about metaclasses. And I think it was, this is how old I am. I think it was like 2005 when they first started talking about metaclasses. And at PyCon, I went to a talk on metaclasses. And one of the things they told me was that if I didn't already know what they were, I would never need to use them. And I was so happy because it's just weird stuff. But let's look at metaclasses. So again, everything is an object, including classes, which are types, and they all inherit from type. Even object inherits from type. Suppose then we take the type object and we inherit from type, but we override some stuff. Okay, that ought to be possible. And that would mean we could define a mechanism for creating classes that behave differently. So we could make, for example, classes that automatically registered themselves when they're instantiated or something like that. This is popular, or at least used to be, I haven't looked into it for a while, with ORMs, where they magically suddenly seem to know all about your database as part of the actual type. How do they do that? They have a meta class to do that. It also means you can do other things. What I want to suggest we do is, for simplicity's sake, we make a meta class, which is a type of type that will only create singleton classes. Okay, if you're big into singletons for some reason. I'm not particularly, but it's an easy one to do. So what we're going to do to create this meta class is inherit from type. And I'm going to override, not overload, override the dunder call method, which is when you use the class name in parentheses to create a new instance. Okay. Last time I gave this, somebody asked, well, why don't you use new? Well, you could. I chose to use dunder call because it's the very first thing on the string. No other reason than that. And what it's going to do is it's going to check, this class is going to check itself to see if it's already got an instance. If it does, it will return that. If it doesn't, it will make a new one and save it and return that. Okay, so this is the code. This is enough to parse through that you might just have to take my word for it. But it's not too difficult. It's basically class single inherits from type. That's pretty standard. And I am going to override the dunder call method, which gets all of that standard stuff as an argument. It gets the class, it gets positional arguments, keyword arguments. That's all the same. Basically, it checks using hasAttr to see if there's already an instance attribute in that class, if there's already a class attribute to store the instance. If it doesn't have that, it must not have been instantiated yet. So it will go ahead and print a message saying, oh, there's no class, I'm going to make one for you now. And it will then call types dunder call with all of its parameters to do the actual work of creating the class. Okay, and it will save that as instance attribute for the class that we're currently in. And then print out a little message, it's returning it, and return it, and that's it. So the first time that you try to instantiate something, it will go through all of that stuff, make a new one, save it, and pass it back. Any other time, it will say, oh, no, wait, I've got an instance already, and it will just return that. Okay, so we do that. And again, class single is a type, shouldn't be a surprise. And then we can go ahead and we can make a class. We haven't actually made a singleton yet. We're just making the singleton class. We can make a class singleton, and instead of using type, we use the meta class parameter to say, don't use type. Use this thing we just created up above, class single. Okay, so that is using the meta class. Okay, we do that, and I now have a class singleton, and its type is main class single, no longer type. If I go to create an instance, it says, oh, I don't have an instance yet. Let me make that for you. Here you are. Okay. If I go to create a second instance, it says, here, I've got an instance. You can just take this one that's already made. And in fact, if I check their IDs, they're the same thing. So I'll have a singleton. And if I decide I need lots of singletons, I can make another class, and I can do the same thing. Again, first time it runs all the stuff, second time, third time, on to indefinite number of times, it will just return the same thing. Okay, so that is how metaclasses behave. It's not as weird as you might think, given all of the other weirdness we've gone through along the way. Given the fact that objects and types are related the way they are, given the way that inheritance works the way it does, if we overload type, or excuse me, if we override types, attributes by inheritance, we can do different things. All of that works out to, in a way, make sense. It's one of the things that I find really entertaining about Python is if you follow all of the assumptions, it makes sense in remarkable ways. So again, metaclasses, I encourage you to poke at them and have all sorts of fun. If you download the notebook, there's another one that will actually take the whole singleton class thing a step further, but I don't want to spoil the surprise. You can go get it. But again, I would not recommend you trying to work it into production. The wisdom, again, that I learned in 2005, 2007, whatever it was, is if you don't already know why you absolutely must use a metaclass, you don't need it. So that in fact is it. And I'll get to your question in a second. To sum up, here, you could have just waited for these 4 lines and that was it. Everything almost is an object, which is a type, and classes are objects, and you can alter them on the fly, and you can actually change even how they're made by messing with metaclasses. That's it. Okay, so that is it. There's the QR code again, if you want to download that. And if you have any questions, I think there was one back there. I'd be happy to make something up.
How would this last example have been different if singleton class was a parent and not a metaclass? You specified metaclass if it was a singleton class, but if it was just a parent class?
That would also work. The thing is, the thing with what I did there is that we can create endless classes just by doing that. And probably we could do more things that wouldn't be as easy to do with just inheriting. You could do the singleton by inheritance. Yes, I don't, no argument there. But this is kind of just taking it one level kind of, I don't know, further down, further up. I don't know how you want to look at that. But so, yeah, I mean, there would be different ways to do it.
But the dunder class method gets inherited.
Yeah. Yes, sir.
So I have 2 questions. I could repeat one if so, but broadly, when you mentioned like you'll know if you need meta classes, like you'll know when to use them, kind of thing. Are there like common examples where you see them like that come to mind as far as when people tend to overuse them, when an alternative, maybe simpler method might be available? Sense of things to look out for.
It's kind of a case where it doesn't happen so much because by the time you get to the point where you want to, you know enough to feel confident using them, you probably know enough not to use them. I do recall having a junior developer. We were doing a lot of web scraping, and he created these sort of complicated classes to pick out various things we wanted. We were scraping for prices, so there was, he did it all very object oriented. He was just out of college. What do you want, And I think he used a meta class for that, and I think I eventually counseled him away from that. Something like that. Yeah. Yes, sir.
So with the meta classes, you mentioned that ORMs like Django, I know
Yeah.
this, where does like the implementation logic for that go in the kind of in the example?
I'm assuming that it's been years, so I don't know, but I think it's probably in new. Because new is where, you know, the things sort of get allocated and get put together in sort of as type works. So I'm thinking that.
So to add that, like, if you see Django, so they do it in new as well as in under prepare, because that gets like one step above new, and they want to have total control about like all these.
Yeah, could be,
classes.
could be.
Because we write when we do model and we write one class inside that thing. So for that, like they need to have total control on the class body itself that we can't get from new. So they do.
Okay.
That was one.
Yeah, I mean, like I say, I haven't looked at it, but that makes sense. Yeah, I'd buy that.
I have one question.
We've got one in the back first, I think.
Yeah, is there any way to step through the memory when you change the, I guess, the function of the class? Because it kind of sounds like it's like changing the function pointer under the hood. So I was just curious if that was.
Well, it changes the reference, yeah, because basically a class is actually really just a bunch of dictionary mappings with a little bit of extra dressing. So it just changes the reference in that dictionary. So it's not even, I don't think it's even as deep down as you're suggesting. It's just a simple remapping a dictionary value to the key.
Okay, so it's just that.
And it's more complicated than that, but basically functionally it's that.
Okay.
Yeah, you're there.
Yeah. So like this is something I have to search. So like, but one question was, when this is something I have seen like that been practiced all over when I see Python code, that if I want to express something that is missing, I usually use something is missing is equal to object. And in this case, I use object as a sentinel. So why is it like, because when we consider like object, like everything, almost everything is an object. So I can make none also as a missing value, but now it happens that none is a singleton in this case.
Mm-hmm.
So why can't I use missing, like something is missing in this dictionary? For example, when I do something which is missing, like if this is missing, then I use object in that case to like suppress something. Why can't I just use none in that case? Like, I hope like that makes sense.
Well, I mean, object has the advantage that object itself is, I think it's mostly immutable. I'm not sure if there's some ways that you can't add an attribute to object. It's just, if you make an object, it's just an object. I mean, it's not going to be something that people can mess with. So in that regard, I suppose it's not so bad. I mean, in terms of what your code is going to do when it hits that object and how it's going to interpret it, I'm not sure that's always the most obvious thing. So I don't know.
Thank you.
Yeah.
You mentioned that this could produce code that was undebuggable. Do you remember in what way PDB screws up when you try to debug it?
I'm not sure that it's not like absolutely untraceable. It's kind of a way that you can create your own sort of self-modifying spaghetti code is more what I'm talking about. Yeah. I mean, you can step through it, and if it's now going into the new function or the new whatever, you will go there. It's just when you're looking at the code in front of you and trying to follow that state mentally, it suddenly does a switch on you and you have to follow that switch as well. So that's more what I was talking about. It's just a way to give yourself a headache. Anything else? Well, thank you so much for your time.